Hello everyone, I'm Mohammad Ibrahim Shah. I'm currently an MSc student in the Department of Resource Economics and Environmental Sociology under the supervision of Dr. Frank Chu and Dr. Martin Lukert. Today, the paper that I'm going to present is about the stochastic assessment of financial viability of biojet in North America. Currently, 35% of the trade volume worldwide consists of the air travel, and over 3.8 billion passengers are transported by air. But according to International Air Transport Association, this is going to double within the next 20 years. As such, global carbon dioxide emission from the aviation industry will rise to about 3.1 billion tons within 2050, which is currently just 705 billion tons. That's why we need alternative jet fuel which can reduce the CO2 emission from the aviation industry. These alternative jet fuels may include synthetic jet fuel, electricity, hydrogen, electrofuels, and many more. But they are constrained by the issues such as the lack of drop-in capability, energy, and emission density. Traditionally, aviation industry depends on petroleum-based aviation fuel and has developed infrastructures that are specifically designed for this fossil fuel-based technology. As such, we cannot get rid of them overnight. What is then needed is a renewable drop-in fuel that can be readily used without any significant modification to the existing infrastructure and that can be blended easily with the traditional fuels. That's where the biojet fuel comes in, because it is a renewable drop-in fuel which can be readily used with the existing infrastructures. There are other multiple benefits associated with the biojet production. For example, it can significantly reduce the life cycle CO2 emission from the aviation industry. It also has more flexibility in terms of feedstock and technology available. However, the production of biojet has not yet been feasible from a financial viewpoint, and there are different types of uncertainty which add more unfavorable conditions to the development of biojet fuel. These uncertainties may come from different stages of production. For example, they might come from availability and cost of the feedstock at the first stage, cost of utilities at the processing plant stage, prices at the fuel blending stage, or the yield of biojet and its co-product at the final stage. In our modeling, we will have to take account of these uncertainties. However, most existing literature has not yet addressed these numerous sources of uncertainty that arise from different stages of production. Some studies have addressed this type of uncertainties using a stochastic distribution when assessing economic viability, but they have mostly applied inappropriate distributions owing to the lack of data. In this research, we will select distribution on the basis of data collected from a comprehensive literature review that are out there. At the first stage, we will have to select the distribution because this is an important part of our research. In selecting the distributions, we will follow a certain criteria. For example, we will first see how our data is, and then plot the histogram as well as the cumulative distribution function against the theoretical densities of different distributions. For example, here I plot the fixed capital stock per yield data for from our biojet plant. And then we feed that fixed capital cost against the theoretical densities of different distributions such as exponential, normal, log normal, Weibull, logistic, Cauchy, and uniform. And we try to see which distribution will it fit the better. And this is the same case with the cumulative distribution function, where we try to see which cumulative distribution function that our capital cost is fitting better. And we have lots of parameters. We'll have to select the distribution in the similar way for all those parameters. And then after selecting the distributions, we'll use a net present value framework approach within the Monte Carlo simulation to evaluate the financial viability of biojet in the North American context. We'll consider the HEFA production pathway, which is the most financially viable and mature pathway yet among the approved production pathways for biojet. This HEFA pathway uses the vegetable oil, used cooking oil, and animal fats as feedstock. In our research, we hope that we will be able to improve the assessment of uncertainties and contribute to the economic evaluation of biojet production. Thank you.